Now we're ready for our last presentation. Actually, we're in this round of lightning talks. Todd Kerpelman, developer Plaidvocate at Plaid, will share his experience on building an AI-powered chatbot for Plaid's documentation site. Looking forward to this. Todd, on to you.
All right. Thank you. Can you hear me? Get a thumbs up. All right. Excellent. Hi, everybody. So I'm here to talk to you today about what I learned building an AI-powered chatbot for our doc site. I think this is the longest title I have had for a presentation up until now. And I only have 15 minutes, so I'm just going to get right into it. So this here is Bill. This is if you were to go and visit Plaid's documentation site and head up over to the search bar up on top, you'll notice that in addition to being able to search our docs, you can ask a question. And so this is something a coworker sent to me. I got dumped by a girlfriend, which Plaid product will help me recover. I guess he's going through some stuff. But what's interesting is like Bill was able to provide a pretty good answer. This is a question that I don't think we had anticipated, but it does a pretty good job. So this is what we have. You can try it out today if you want to visit our documentation page, if you browse documentation pages for fun. I'm going to talk to you today about sort of how we built this and why we built this. So like many fun features, Bill started out as a hackathon project. This is sort of what we were able to build after just a few days of hacking at Plaid's annual hackathon. And I'm not going to go into like all the nitty gritty details on how this works because there's frankly lots of videos and blog posts out there already that go into this in a lot of detail. But I do want to give you a high level overview because I think it's important to sort of understand, how these work in general. And, that might explain some of our decisions later. So if you want to build a docbot that is sort of trained on your documentation, you kind of have to perform a few steps. First thing you got to do is take all of your content and chop it up into little pieces. So we took all of the content that we felt like a docbot should know about. And for us, that's our documentation pages. We have some implementation guides in PDF form. We have a lot of YouTube video tutorials that we grab transcripts for and so on. You take all that content and you chop them up into pieces that are about 400 words each. You don't have to do this manually. There's lots of libraries out there that help you do this. And then once you have these chunks of 400 words, you basically need to kind of distill it down to a single meaning that is represented as a point in space. And that's kind of a weird concept. So let me show you an example. You can kind of see here, we have like a 2D graph where we've got hot weather activities and cold weather activities on the y-axis and things that are chores versus things that are fun in the x-axis. And you can see that there are some things that are sort of naturally close together, right? Like hanging out at the beach and hanging out at the pool are kind of clustered together. Shoveling snow, putting chains in your tires are kind of clustered together, right? And this is what we do basically for our documentation content, except that instead of a 2D space like this, it's in a 1500 dimensional space. But drawing in 1500 dimensions is really hard in Google Slides, so you're just going to have to imagine it. And to do this, we used an API, one that was provided for us by OpenAI called the Embeddings API. You feed in a bunch of text, and it sort of gives you back a point in 1500 dimensional space that represents the meaning of that text. Once we have that giant vector, the next thing we do is store these in a database. And there are vector databases that are designed specifically for sort of quickly searching and storing vectors that might be close to other vectors. So we take that vector, store it in this vector database, include the original source text that was used to generate that vector in the first place. And, in our case, we also included the URL where sort of that text originally came from. Now that we have all this stored in a database, here's what we do. When a user asks a question, the first thing we want to do is convert that question into a vector. And we will do that by sort of sending it to the same embeddings API that we were using to embed all of our original documentation content. Excuse me. Once we're done with that, we have a vector, and we can send that vector to our vector database and say, hey there, database, can you find the 3 or 4 vectors that are closest to this one that we sent you? And once you have that, please send us back the text that's originally associated with these vectors. And so what you get is several chunks of documentation that are pretty likely to be relevant to the user's original question. Then once you have this extra data, you can send that along to your LLM. In our case, we were using GPT-4 by OpenAI. And so, you send GPT the user's original question alongside all the documents that you grabbed from your vector database. And you say, hey, can you answer this question? Probably with the use of this documentation. I think I just set off Siri. Hopefully I won't do anything weird. And it ends up giving you back a fairly accurate, actually, I would say surprisingly accurate answer. It's able to sort of look at the content, look at the question, and give you back a pretty accurate answer. For those of you that are into prompts, this is essentially the prompt that we sent to our AI. Hey, you're a chatbot designed to help developers be more successful using Plaid. Here's the user's question. Here's some documentation that might be helpful in answering the user's question. Please give us an answer. This is a slightly simplified version, so it could all fit in a slide, but it's basically the general idea. My favorite analogy for describing this is it's not like studying for an exam. Like in the end, our AI doesn't really learn about our documentation. It's more like showing up for an open note test with a magical textbook that always opens to the right page every time, right? You basically have all the documentation, all the notes you need to kind of BS your way into a correct answer. And so that's basically how our chatbot works. And so after building our successful prototype, we were sort of faced with a decision. Do we want to continue sort of building this into a real product, or should we just go and buy something? There, sort of around the time that we were doing this, there were a number of startups that are also doing, hey, we'll give you a chatbot based on your documentation site. And actually, since then, a few other startups have popped up that are all sort of offering this. And we sort of evaluated some of these early on. And basically, it seems like they're all following about the same strategy that ours was, in that, it's doing the same, take your documentation, break it up, put it in a vector database, send it all to GPT. And so what we found is on almost all these chatbots, the quality of answers we were getting were almost the same as what we were able to create, sort of building it in-house, which leads to, I think sort of half our team came to a very obvious conclusion, which is, well, why should we spend our time building something when we could, shell out a few bucks and get something nearly as good right away? And then the other half of our team came to a very obvious conclusion, which is, why should we spend money on a third-party solution when, you could build something just as good all by yourself? And so, there were a lot of the usual sort of build versus buy trade-offs. Like if you build it yourself, it'll probably be less expensive in the long run because there's not sort of another company out there that needs to be profitable. You'll have sort of more fine-tuned control over everything, probably a better experience, so on and so forth. On the other hand, if you choose to go with a third-party solution, it's going to get to market a whole lot faster. You can honestly, with some of these third-party solutions, probably get a chatbot, roughly working in like a day or two. Get a crude version in a day, probably get it nicer over, a week or so. And these third-party solutions have dedicated engineering teams that will probably make their product better over time. In the end, though, I think one reason we chose to build this internally is this reason right here. We got to learn a lot about LLMs and about AI, and I'm pretty sure that AI is not going away. And, for us, Plaid has sort of a very strong culture around personal growth and learning new things. And obviously, one of the best ways to learn something new is, to try building it yourself. And, at some point, I think we are going to be building tools that, sort of use some kind of AI, some kind of LLMs that can't be built by a third party. And, it's nice that we have this knowledge internally based on sort of our prior experience trying to build Bill. Of course, the drawback is obvious to anybody who said, oh, I could build Twitter in a weekend. You can't. And I definitely underestimated the time it took to, turn this into an actual product. But, eventually we did get it out there. I do think it's important to set expectations when you're doing this. When we first were doing the hackathon project, we had no idea sort of what this DocBot was capable of. We're like, maybe we don't need documentation in the future. The bot will just sort of guide all our developers, and they'll just ask the bot to build stuff for them. That's not true. You're still going to need to write documentation. In fact, a good DocBot is highly dependent on having good documentation, but it can make your documentation experience better in sort of three main ways. It's really good at synthesizing information that's spread across different pages. Bill can compare like two different Plaid products that sound very similar, but actually aren't. It can often be a better search experience than search. Search is great if you know the thing that you're searching for, but if you don't know the term, if you don't know if the thing even exists and you can only describe your problem, sometimes Bill is really good at pointing you to content to learn more. And I think it's also very good at taking generic documentation and rephrasing it for your user's specific use case. I used to work at Firebase, and we have very good documentation that describes sort of at a high level, like how Firebase sort of stores and indexes and searches through data. And oftentimes developers didn't want that. They wanted specific documentation on how to build an Instagram clone because they were building an Instagram clone. That's hard to do, but a chatbot can kind of do that for you. It can take your generic documentation and make it very specific for your use case. Also, you are still going to need a support team, but you can make their lives better. I would say, roughly oversimplifying things, your support team is going to have sort of two groups of questions, two categories. The questions that probably could have been answered from your documentation and the questions that actually need a support team, like, we're having trouble with our account, or this thing that should be working isn't working. Can you check your internal logs and tell us why? Things like that. And so by having a DocBot hopefully sort of intercept a lot of those questions in the first category, you can make sure that your support team has more time to spend on the questions they really should be answering, all the ones in the second category. Here's a bunch of technical decisions compressed into a single slide because, again, I only have 15 minutes. We used GPT-4 over GPT 3.5 Turbo. And for a lot of developers that have been working with GPT, they were sort of surprised by that because, GPT-4 is like 20 times more expensive. And so I think a lot of developers just kind of discount it right away. But I would say, maybe that's okay. Like for us, we are not, we're not React. We don't have like millions of developers using us for free, right? We have thousands of developers using us and, they are, or hopefully will be paying customers. And so from our perspective, it just sort of made sense economically to sort of spend that additional money on our OpenAI costs, if it helps our developers be more successful in the long run. And, realistically, we probably spend 10 to 20 cents per question on our OpenAI costs. And, again, for the number of developers we have, for sort of, given the fact that they all hopefully will be paying customers, that for us is totally worth it. We used LangChain, but I would point out it's not a panacea. LangChain is a library, if you don't know, that sort of makes it easier to, talk to, these AI endpoints. It makes it easier to do the grabbing your data and chopping it up. But I actually noticed talking to other engineers in the company who were working on their own AI projects, they didn't necessarily use LangChain. They, just talked to the AI endpoints directly. And I would say LangChain is really good at sort of taking complicated processes and condensing it down into like a single line of code. But if you need to modify those processes in any way, you often end up needing to kind of recreate a lot of the stuff that LangChain does. So I'm still happy I used it, but I would say don't feel like you need to be obligated to use it. It's just sort of a helpful library. We used Pinecone as our vector database. We used OpenAI as our LLM. I think probably for both of these, it was just because one, at the time we have a internal tools team that had vetted both of these, and they sort of met with all of our requirements regarding security and all of that. And also, they were sort of industry standard, I would say, at the time. I mean, they still kind of are, which means that sort of there's a lot of, supporting information and tutorials out there already. How do you evaluate the performance of an LLM? Like, this is not easy, right? You will get lots of very plausible sounding answers from, your chatbot. How can you tell if they're right or not, right? These both sound right. One of them is very wrong. The first line of defense is ask GPT to grade itself, right? We sort of have a series of questions and sort of ideal answers that those questions, that those answers should contain. And what we do is we have a Python script that sends those questions to Bill. And then we take those answers and we send them back to GPT and say, hey, this is the answer we got from our chatbot. These are the talking points an ideal answer should contain. How'd they do? How'd you do? Grade yourself on a score of like 0 to 100. And this does pretty well. This is good for sort of like broad stroke, oh, we updated our database, did we break something kinds of tests. But ultimately, oh, there's a typo. We review these ourselves. In the end, you kind of need a human who knows about your product to sort of double check Bill's answers. And in our case, we had a manager who spot checked all the questions. Well, not all, some of the questions that Bill gave us, and, generally determined that for the most part, Bill got these answers correct. But yeah, you do still kind of need a human, at least for now. What happens if something goes wrong? First thing, check and see if the docs are complete. oftentimes Bill missed an answer because something that we thought was in the docs was not in it. And we could fix it easily just by adding that stuff to the docs. Stuff that we thought was explicit was just sort of implicit. After that, it gets tricky. Sometimes that information is out there. Bill should have gotten the answer, but it didn't. And sometimes you can fix it by figuring out how you're parsing this information. But sometimes the easiest way is just feed the answer directly to your chatbot through a separate text file. So in addition to all of your documentation, you would just take a separate text file and put it in. So I had a little bit on security. You're just going to have to, I guess, come back and review this YouTube recording to see it, because I am out of time. But if you want to find out more, because I did have to rush, head on over to my blog. It's kerp.blog, and I have a post, I think it's the first one there, that goes into a lot more detail on sort of all these topics. Or, reach out to me on LinkedIn. And with that, thank you very much. I am out of time.
Todd, amazing. That was a lot of information indeed, concise, but I think we are going to get a lot of interest and even rewatching your
network connection.
Sorry, can you hear me, Todd? Well, thank you, Todd.
There we go.
Can you hear me now? Okay, great. Thank you, Todd. Welcome. That was an excellent presentation. And I will tell the audience, if you have any more questions or wish to discuss with Lisa, Paul, or Todd, please drop by DevRelX channel on Slack. I'm sure they're happy to answer any of your questions.